All right, we're continuing on here in lesson 1A here on unit rates. And we have this final kind of problem here, which is extending a unit rate then to finding out how much something is going to be, use the unit rate to make another calculation and answer another question, solve another problem. Okay, so Lexi here showed that she painted 2 faces in 8 minutes, okay, at the craft fair. And at this rate, how many faces can she paint in 40 minutes? Now, these numbers are very easy, which the book does a lot. Okay, they'll give you very easy numbers that you can do this in your head probably without even calculating a unit rate. And that's what this bar diagram is. If the numbers are so easy that you can calculate them in your head, kind of doing this bar diagram in your head, okay, then you don't need to use the unit rate. Okay, but you also don't need to write anything down, really. Okay. If it's 2 faces in 8 minutes, then how many in 40 minutes? And you know that you can tell here from this that it's 1 face every 4 minutes. Okay, 1 face every 4 minutes. And so in 40 minutes, that's 10 faces, 40 divided by 4. Or 40 is 5 times 8 minutes because you know your times tables. And these are easy numbers. Well, if it's 5 times as much time, then it's 5 times as many faces. And so the answer is 10 faces. Okay, that problem is one you should do in your head. Okay, the book is good at giving you these easy numbers. Life doesn't work like this stuff. Okay, so it's not very common that these numbers are easy. And if they're not easy numbers and you don't see this right away, then this is not the right method. Now, if you do see this right away and you can write the answer, that's okay, but I'm not going to give you problems like that, okay? Instead, I'm going to give you problems that you can't do in your head. And then you use this method too, which is to calculate the unit rate and then multiply by the number of units that you are looking for, okay? So in this example, even though these are easy numbers, okay, you find the unit rate, okay? The unit rate is the unit rate is 2 faces per 8 minutes. Okay, how many faces per minute is what we're looking for. So it's 2 divided by 8. That's what they show right here. So this is what you show, 2 divided by 8, and that comes out to 0.25 faces per minute. That's your unit rate. A quarter of a face, 0.25, 1/4 of a face per minute. Okay, now, if the question is, how many can she paint in 40 minutes? Then you multiply this 0.25 times 40, okay? Don't worry too much about them showing how these units cancel out. That, again, is so simple in this problem that you don't have to write that. You do need to write 0.25 times 40. And these in the middle of the work here, you really don't need to write your units all the time in the middle of the calculations, but you always have to have units in your final answer, right? This is good because faces per minute shows you the unit rate, and then you multiply, and your final answer is 10 faces, okay? So you can use either method, but note what I say here. This method, the unit rate method is safe and works I cannot get this to go. Works for any numbers. Okay, the unit rate works for any numbers. So this is the method to use unless the numbers are so simple you can do them in your head, which I'm not going to give you problems like that. All right, so the book doesn't give too many good example problems here, so I want to do a couple of examples of this for a little bit more challenging parts of this unit rate question. All right, so first, and the thing that happens here is sometimes there's packages and the unit that you're talking about could be different things in the same packaging, right? So this one is a bag of Hershey's miniatures. I love me some Hershey's miniatures. Crackle is my favorite, but Mr. Goodbar, also excellent. Okay, so there's a 12-ounce bag of Hershey's miniatures. It costs $3.79. Okay, so and which one is your favorite? I gotta go with Mr. Goodbar. Let me say that's my favorite, mystery bar. Okay, that's just me. All right. So there's a different question. You can't just ask what's the unit price for this bag, because what's the unit? Is it how much per each bar, or is it how much per ounce, or how much per pound? Right? So you have to specify a unit. Now, when you're comparing things, as long as you use the same units, then that comparison will work. Okay, this isn't a comparing question. This is just really finding the unit price. So what is the unit price per ounce of chocolate in this bag? Well, it says it's a 12-ounce bag, and it costs $3.79. So dollars per ounce is going to be $3.75 divided by 12. Okay, and so that's going to give me an answer of 32 cents per ounce. 32 cents per ounce. Now, if you wanted to know what the cost was for each of the candy bars in here, okay, per candy bar, what information would you have to have? Because it doesn't say anything. I mean, how do I get the cost per candy bar? There's two ways I could answer it. Okay, first, so what are the two ways? There's two answers. Okay, the first way is if you knew how many ounces there were in each candy bar. Okay, if you knew how many ounces there were in each candy bar, okay, then you could, so if I told you each bar is about 0.4 ounces, now you could answer this question, right? How much is each bar? Well, you know that the chocolate is 32 cents per ounce, and if each bar is 0.4 ounces, then you could multiply this 0.32 times 0.4. I wonder if that's what I did. Okay. Okay. And get the answer. Okay. This would tell you how many bars. You could also figure out how many bars are in the bag, which is a more normal calculation. Okay. So if it's 12 ounces and each bar is 0.4, then 12 ounces divided by 0.4 ounces per bar will give you 30 chocolate bars. A little more complicated. Okay, or the other thing you could figure out is if they just told you how many bars were in the bag. Sometimes it'll say that on the packaging. It'll say about 35 servings or something like that. Okay, so it turns out that this bag has about 30 bars, right, which we calculated over here, but that's what you might be given that number. And then what's the price per bar? Well, then you do $3.79 divided by 30, right? The price divided by the number of units, the number of bars, and it turns out that this package is about 13 cents per bar. 13 cents per bar. The other way you could get it, which I didn't really think about until just now, is that over here, if you knew each bar was 0.4 ounces, and you already calculated that it was 32 cents per ounce, you could just do 0.32 times 0.4. Okay, 0.32 times 0.4 comes out to about 13 cents per bar. It's actually 12.8 cents per bar. Okay? All right, so here's one for you to do, comparing orange juices. Okay? So you can buy a single big jug of orange juice for $5.48, or you can buy a 6-pack of 12-ounce bottles of orange juice for $4.23. So which one is the better buy? First, you have to find the unit rate, and your unit rates have to have the same units to compare them. So we're going to have to figure out ounces for each one. Right? How many ounces of orange juice are there here for $5.48? And how many ounces are there here for $4.23? So 89 ounces, this one's easy. So $5.48, $5.48 divided by 89 ounces is 0.062 cents per ounce. Now, this 6 cents, a very small number. You definitely are going to need to go to the third decimal place here, to the thousandths of a dollar or tenths of a cent. to compare these, okay? Because 6 cents, they'll both come out to 6 cents. Very common that would happen. Okay, so go one more decimal place. So 6.2 cents per ounce, okay? Now the 6-pack, how many ounces are there in the 6-pack? So you got to figure that out first. It's 6 12-ounce bottles, okay? Which means 72 ounces. That's 6 times 12 is 72 ounces, okay? So 72 ounces for $4.23. And what does that come out to? That comes out to 5.9 cents per ounce. Now again, see, if you didn't round this, to take another decimal place here, these would both come out to be 6 cents per ounce. And you'd say, oh, they're the same price, but they're not. This one is 6.2 cents per ounce, and this one is 5.9 cents per ounce. So that's why you have to go to an extra decimal place there to figure out which one really is the better buy. And the answer is that the 6-pack, okay, the 6-pack is the better buy because it is 59 cents versus 62. So it's actually better by, what is happening? Come on, guy. Actually better by 3.3 cents per ounce cheaper. Okay, but it is the lower unit price.